Welcome to video lecture. Myself Ashwini R.K., Assistant Professor, Civil Department, Jogni College of Engineering and Technology. Today we are going to see about model analysis. Model analysis is actually an experimental method of finding solutions of complex flow problems. The following are the advantages of the model analysis. The performance of a hydraulic structure can be predicted in advance from its model. Using dimensional analysis, a relation between the variables influencing a flow problem is obtained, which helps in conducting tests. The merits of alternative design can be predicted with the help of model analysis to adopt most economical and safe design. Tests performed on models can be utilized for obtaining in advance useful information about the performance of the prototype only if a complete similarity exists between the model and the prototype. Similitude or types of similarities. Similitude is defined as a similarity between the model and the prototype in every respect, which means model and prototype have similar properties or model and prototype are completely similar. There are three types of similarities must exist between model and prototype: geometric similarity, kinematic similarity, and dynamic similarity. Geometric similarity. Geometric similarity is a similarity of shape. It's said that it is said to exist between model and prototype if the ratio of all the corresponding linear dimensions in the model and prototypes are equal. That is, LP by LM is equal to BP by BM is equal to DP by DM is equal to LR, where LP, BP and DP are length, breadth and diameter of prototype, and LM, BM, DM are length, breadth and diameter of model, and that LR represents the scalar ratio. Models are generally prepared with same scale ratios in every direction. Such a model is called as true model. However, sometimes it is not possible to do so, and different convenience scales are used in different directions. Such a model is called as distorted model. Kinematic similarity. Kinematic similarity is a similarity of motion. It is said to exist between model and prototype if the ratio of velocity and acceleration at the corresponding points in the model and prototype are equal. That is, Vp1 divided by Vm1 is equal to Vp2 by Vm2, that is equal to Vr, or AP1 divided by AM1 is equal to AP2 by AM2 is equal to AR, where this Vp1 and Vp2 and AP1 and AP2 are velocity and acceleration at point 1 and 2 in prototype, and Vm1 and Vm2 and AM1 and AM2 are velocity and acceleration at point 1 and 2 in model, and VR and AR are the velocity ratio and acceleration ratio. Since the velocity and acceleration are vector quantities, hence not only the ratio of magnitude of velocity and acceleration at a corresponding point in the model and the prototype should be same, but the direction of velocity and acceleration at the corresponding points in the model and prototype should also be parallel. Dynamic similarity. Dynamic similarity is the similarity of forces. It's said to exist between the model and prototype if the ratio of forces at the corresponding points in model and prototype are equal. That is, Fi of P F divided by Fi of M is equal to Fv of P divided by Fv of M is equal to Fg of P divided by Fg of M, that is equal to Fr, where Fi of P and Fv of P and Fg of P are inertia, viscous and gravitational forces in prototype, and Fi of M Fv of m and Fg of m are inertia, viscous and gravitational forces in model, and Fr is the force ratio. The direction of forces at the corresponding points in model and prototype should be parallel. Various types of forces encountered in the fluid phenomenon. First one is inertia force, that is represented by Fi. It is equal to the product of mass and acceleration in the flowing fluid. Second one, viscous force, represented as Fv. It is equal to the product of shear stress due to viscosity and surface area of flow. Third one is gravity force, represented as Fg. It is equal to product of mass and acceleration due to gravity. Fourth one is pressure force, represented as Fp. It is equal to product of pressure intensity and cross-sectional area of flowing fluid. Fifth is surface tension force, represented as Fs. It is equal to the product of surface tension and length of surface of flowing fluid. Last, elastic force, that is represented as Fe. It is equal to the product of elastic stress and area of flowing fluid. Thank you.